Welcome to the video on scientific notation. Scientific notation is a way of expressing a very large or very small number more easily using power of 10. The coefficient is the actual value. So that's the number. So here we have 2 and 4, and here we have 8 and 6. That's the coefficient. The second important piece is going to be the power of 10, and that's going to be where the decimal is placed. For example, we have 3 places here, and here we have 4 places. So the power of 10 is going to be the second half of our scientific notation, and that's going to tell us where the decimal point is. So one quick hint, if we have a big number, one that is much greater than 1, then we're going to have an exponent on our power of 10 that is positive. And if we have a small number, meaning that the decimal place, the zeros come before our number, meaning the number is less than 1, then we are going to have an exponent on the 10 that is negative. So that gives you a little bit of a trick there. And so now, if we look at the coefficient for the first problem, we have a 2 and a 4. Now, proper scientific notation tells us that we can have one digit before our decimal. So this is going to have to be 2.4. We don't include the zeros. We just have the 2 and the 4. And now we have to figure out the power of 10. And so the way we figure out the power of 10 is we have to decide here is where our original decimal was in our value, and we are moving that decimal over 1, 2, 3 places to put our decimal here. So if we put our decimal here, then we have 3, and it's a big number, so we have 10 to the third. So our scientific notation of 2,400 is going to be 2.4 times 10 to the third. Now, if we look at our second example, the two digits that we have, the two numbers that we have, the two values that we have are 8 and 6. So I'm going to put 8 and 6 there. Scientific notation, we're just going to have the decimal place there because we just need one digit. So we have 8.6. And now we have to go to our power of 10. And our power of 10 here's our original decimal place. And because it's a very, very small number, we're going to move our decimal place to the right, which means we're going to have a negative number. So here. Now, if we move that decimal place 1, 2, 3, 4 places, it puts it so that we have one digit before the decimal. And so that was 4. And so we have times 10 to the negative 4. And so what does 2.4 times 10 to the third mean? What it means is 2.4 times 10 times 10 times 10. We're taking that 2.4 and we're multiplying it by 10, then by 10, then by 10. Or 2.4 times 10 to the third. What does 8.6 times 10 to the negative fourth mean? That means 8.6 times 1 over 10 times 1 over 10 times 1 over 10 times 1 over 10. Another way to say this is that we're dividing by 10. So we have 8.6 divided by 10, divided by 10, divided by 10, divided by 10. Multiplying by 1/10 is the same thing as dividing by 10. And so that ultimately gets you our original question. Another way to look at that, if we have a negative exponent, we're going to move our decimal place 1, 2, 3, 4. 1, 2, 3 zeros in the front. 1, 2, 3 zeros in the front. And so there you have it. And so that's what scientific notation means. If it's a positive exponent here, as in the top example, we're going to multiply by 10. And when we have a negative value, 10 to the minus 4, that means that we have a very small number, and we will either divide by 10 or multiply by 1 over 10. And so here are some practice problems. For scientific notation, we're going to want to put the decimal here. In order to do that, we're going to need to move the decimal 1, 2, 3, 4 places. And so our digits are 5.5 times 10 to the fourth. And it's a positive number because our original number is greater than 1. If we look at the second example, we're going to want to put the decimal place here. So we're going to have 7.2. And now we have to figure out our exponent. And so we have it 1, 2, 3 places. And so we're going to have times 10 to the negative third. The way that we know it's negative is that our value is smaller than 1. It might be nice if you could pause the video right here and try some for yourself. See you in a sec. And if we move down one more, our digits are 1.4. We want our decimal to go there. And so we have 1, 2, 3, 4. And so this is going to be times 10 to the negative fourth. Again, this number is smaller than 1. And so we have a negative exponent in our scientific notation. If we move up to the top here, we want our decimal place to go here. And so we have 1, 2, 3, 4, 5, 6. And so we're going to have 5 times 10 to the 6. Again, our decimal place would go right there. You don't have to put it in, but we need one digit in front of the decimal place. And so that satisfies that. 480, put that into scientific notation. We want the decimal to go there. And so we move it 1, 2. So this one is 4.8 times 10 to the second. Again, that number's larger than 1. We're going to have a positive exponent on that scientific notation. Want our decimal to go here. So it's 6.7. How does our exponent look? We have 1, 2, 3, 4, 5. So this is times 10 to the fifth, and that's a positive number again because our value is greater than 1. Scientific notation is a way of expressing a very large or very small number more easily. Okay, so for the rest of these, they're in scientific notation and they want us to write the number. So here we have 1.2, and we know we have to move the decimal over 4 places, and we want it to be a bigger than 1 number. So we're going to move those to the right. So we have 1, 2, 3, 4. And if you just draw zeros in there, you see that our answer is 12,000. If you wanted to double check your answer, you just do this. And yep, that is 4. So you've drawn enough zeros. And so that is our answer. Okay, 4 times 10 to the 6th. Here's our decimal. So we have 1, 2, 3, 4, 5, 6. And at this point, it might just be easier if we say 1, 2, 3, 4, 5, 6, right? Because if we put zeros in, it'd be 1, 2, 3, 4, 5, 6. And so then we want to draw that with commas every 3, and that's going to be 4 million. It might be nice if you could pause the video right here and try some for yourself. See you in a sec. 3.6 times 10 to the negative fifth. And so we're going to move this over 5. 1, 2, 3, 4, 5. So there's where our decimal goes. 1, 2, 3, 4. So we have 0.123 and then 5, and then there's our value. So that is how we do it. If you want to double check, 1, 2, 3, 4, 5, and that puts the decimal in between the 3 and the 6, which is what we started with. And so that is the correct answer there. 8.25 times 10 to the negative 2. What we want to do is move the decimal 2 places, 1, 2. Our new decimal place is going to be there. And so we have 0.0825. And so you may notice that I've put a 0 in both of these numbers. That 0 before the decimal place is going to just be a nice finishing touch on any of your answers. The answer would not be wrong if you did not put it there. However, it's really the convention is to put that 0 in before the decimal place and then clearly indicate the decimals there and then draw the rest of your number. Okay, 5.8 times 10 to the negative 3. We have 1, 2, 3. And so our new decimal goes here and we have 2 zeros in front. So we have 0.0058. 2.12 times 10 to the fifth. We know that's a positive value, so we're going to move it 5 this way. 1, 2, 3, 4, 5. So that's 1, 2, 3 zeros after the number. So we have 2, 1, 2 with 3 zeros, put in our commas, and that's what we have. And again, if you want to double check, you can always say, okay, if I want to put this back into scientific notation, that's 3, 4, 5, and that's what we came from. And we're going to put our comma in right here. So that's 212,000. One thing we can do to take this just a little bit further is to try to figure out which one is larger. And when numbers are written in scientific notation, it's not always easy to see. Certainly if I have 7.2 times 10 to the third, that's going to move it over 3. So I'm adding 2 zeros. So that's going to be 7,200. And if I have 8.2 times 10 to the second, we're just moving that over 2. So that's going to be 820. So we see that this is much larger, the first one. We might also be able to sneak and see 10 to the third is going to be a bigger value than 10 to the second. Now, in our second example, we have 1 times 10 to the fourth, which is going to be moving the decimal point this way. So we have 1,000 versus 1 times 10 to the negative fourth, where we're going to move it this way, a 0.0001. And so you see here, the positive exponent is going to be a larger value than the negative exponent. Now, if I have 4.5 times 10 to the negative fourth versus 3.2 times 10 to the negative second, 4.5 times 10 to the negative fourth, we're going to have 1, 2, 3, 4. So that means we put 3 zeros in front. So it's 0.00045. And here we have move it over 2. So we just have 1 0. So it's 0.032. And so in this case, the second one is the higher number. So a smaller negative value is a bigger number than a larger negative value in exponents. So now in this case, we have one in scientific notation and one not in scientific notation. That makes it very difficult to distinguish and compare. And so what I'm going to do is I'm going to move the 6.8 times 10 to the negative 2 out of scientific notation, 1, 2. So that's going to be 0.068, and then that's compared to 0.00052. And so we see here that this one is the larger value. And so in this case, let me go back and recircle all my answers. In this case, the larger positive exponent means that it's a bigger number. The positive exponent is going to be bigger than a negative exponent. The smaller negative exponent is going to win. And when you're comparing apples to oranges, you just convert them both to the same, and then you can figure out your answer. Okay? Due in class tomorrow is this page right here. So I want you to decide and show your work. I want you to tell me which one of these is smaller and why. There you have it, scientific notation, just another way that we can use to write and represent a number.